Okay. Today we shall be developing. Today we shall be developing Arch, GARCH, GARCH, EGARCH, and TARCH model. TARCH model. We shall be developing Arch, GARCH, EGARCH, and TARCH model using EVIEWS, and later we shall compare all these five models to find out which one is the best. So that is our task. Today we shall be developing Arch, GARCH, EGARCH, and TARCH model using EVIEWS, and later we shall compare all these five models to find out which one is the best. And here we shall choose AIC and SIC criteria to decide which model is the best, and lower the value of AIC and SIC, better fitted the model. So that is our guideline. That means lower the value of AIC, better the fitted model. So that is the guideline. Okay. And here we can see we have the variable BBR. You can see from here, right? We have the variable BBR. Okay. Variable BBR. You can see from here, right? What is BBR? Bangladesh bond return, right? Bangladesh bond return, and that is BBR. And what is C? C is the constant, right? C is the constant, and our sample size is 200 days. Our sample size is 200 days. So that is our sample size. Okay. Now first I run the model. So what is our model? The first model is like this. The first model, okay, so here we assume that at the very beginning we assume that our variable, that is BBR, is stationary, right? We assume that BBR is stationary, and if it is not stationary, if it is not stationary, then we need to convert it into stationary, and only then we can estimate ARCH and GARCH model. ARCH and GARCH model, meaning that our variable must be stationary. Only then we can run ARCH or GARCH model and so on. And here we assume that our variable, that is BBR, Bangladesh born return, is stationary. Okay, so now we can run the model. Okay, and what is our model? Our model is, the first is the dependent variable, then I take the constant, right? First is the dependent variable, right? Then the constant. So that is our model first. And here there is no other variable. That means only these two, BBR and constant, and there is no other variable. Okay, so I first run the regression line. Okay. Okay. So I go to quick estimate equation. So first I put BBR, then I put constant C. So that is my model, and here BBR is the dependent variable and C is the constant. Okay, I run the model now, and our sample size is 200. That is our sample size, meaning that 200 days data. 200 days. So that our data is from 200 days. Okay, then I run the model. Okay, that is my model, and dependent variable is BBR, Bangladesh born return, and it is the constant, right? And this is the model. Okay, then I check the residual of this model. Okay, so where is the residual? You can see from here, it is the residual of this model. So I click on the residual, it comes up here. Okay, it is the residual. So you can see from here, the residual is this one, this color, the blue color, right? It is the residual of our model. And here what is happening, you see, so and what is this? 200 days. This is the day number 1, day number 2, day number 25, and day number 200 days. 200 days, right? Okay, and these are the residuals, right? The fluctuation is the residuals. Yeah, so this one is the fluctuation of the residual. Okay, from here we can see from day 1 until day 40, right? From day 1 until day 40. So here is the fluctuation is very low, right? You can see the fluctuation is very low for 40 days, about here, right? Okay, but again from the 40 days, so the fluctuation has gone up, right? Has gone up from here to here, meaning that from 40 days until 75 days, the fluctuation is high for long period. And again from 75 until 150 days, the fluctuation has gone down for long period, from 75 days until 150 days. The fluctuation has gone down. Again, from 150 days until 200 days, the fluctuation has again gone up. So what is the symptom? So here what is happening, that is happening here. Meaning that periods of low volatility, tend to be followed by periods of low volatility for a prolonged period, right? For a prolonged period. So meaning that periods of low volatility tend to be followed by periods of low volatility for a prolonged period. Meaning you can see from here to here, so the low volatility is followed by another low volatility for a prolonged period. Again, from here to here, you can see, from here to here, you can see this gap. From here to here, also periods of low volatility tend to be followed by periods of low volatility for a prolonged period. Okay, again the periods of high volatility is followed by periods of high volatility for a prolonged period. So here also from here to here, you can see from here to here, suppose from 40 days until 75 days. So high volatility is followed by another high volatility. And also from here, you can see from here, so from 150 days, right? So high volatility is also followed by another high volatility. So meaning that from the day 150 until the day 200, one high volatility has been followed by another high volatility. So when these things happen, when this thing happen for residual, then we have all justification to run ARCH family model, right? When this thing happen for residual, then we have all justification to run ARCH family model. Okay. But we can double check the whole thing. We can double check the whole thing by appointing ARCH model, right? By appointing ARCH test, not model, by appointing ARCH test. Okay, but we can double check the whole thing by appointing ARCH test whether we should run ARCH family model or not. Okay. Okay, now the question is that how to run ARCH test. That is the question, how to run ARCH test. Okay, here I go to view, then I go to residual diagnostic, then I go to the heteroscedasticity test, right? From here I click it. Okay, from here I choose ARCH model, ARCH test. I choose ARCH test and I click OK. Okay, so this is the ARCH test. You can see from here, and you can see from here the observed R square, right, and the corresponding p value is how much? The p value is here, is around 0.0019, right? And this p value is less than 5%, less than 5%, meaning that we can reject null hypothesis and we can accept alternative hypothesis. Okay, so and what is our null hypothesis? Our null hypothesis is there is no arch effect. And what is our alternative hypothesis? That is, there is arch effect. Okay, there is arch effect. So here we can reject the null hypothesis, meaning that our model has a arch effect. So 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 we can run the arch family model such as GARCH, right? Then EGARCH and the TARCH and so on. Okay. Okay. So actually here what has happened? What has happened here? Okay. Number one, what has happened? Number one, periods of high volatility has been followed by periods of low volatility. What has been happened here? Periods of high volatility has been followed by periods of high volatility for a prolonged period. At the same time, period of low volatility has been followed by the period of low volatility for a prolonged period. So we can easily run the arch model. And secondly, after running the arch test, we have found that there is a arch effect. So we can easily run arch family model. We can easily run arch family model. Okay. Okay. So okay. So I go to estimate. You can see estimate here, right? I click on the estimate. Okay, then this is my dependent variable and this is the constant, and from here I choose the arch family model, the arch model that I choose, and you can see here are many options. Okay, so suppose first I run what model? First I run arch 5 model, meaning that suppose I make GARCH 0 here, right? I make GARCH 0 here. Okay, I make GARCH 0 here, and arch I make 5, right? That means 5 arch and 0 GARCH, and I choose normal distribution. Then I run this model, and here we shall always choose the normal distribution to compare among all the models. Okay, so I choose 5, then I can run the arch model, right? Then I can run the arch model. Okay, so here we are running arch model first, BBR and C. So actually what is this one? This one actually called mean equation. You can see from here mean equation, and this part is called variance equation, right? So this part is what? Mean equation, and this part is the variance equation. Okay, actually what is happening here, and from here, from this part, from this mean part, we shall take the residual from this part, right? We shall take the residual and we shall put the residual in the variance equations. So that we shall be doing now. From this mean model, we shall take the residual, and that residual we shall put in the variance model, right? Meaning that here, this part, okay? And here I choose first GARCH is 0, but ARCH is 5, okay? And here I choose normal Gaussian distribution, right? So then we can run the model, okay? So I click OK. So this is my model. You can see it is the dependent variable BBR, and here I choose normal distributions, and here are 5 arch. You can see it is arch 1, arch 2, arch 3, arch 4, arch 5. But here is no GARCH, only arch is here. And what is this one? This part is what? This part is called mean model, meaning that I can call it mean equation, right? This part is mean equation, and from this mean equation, I have extracted residual and used the residual to estimate variance equation, meaning that this one, this part, right? This part, the whole this part, variance equation, right? So meaning that arch model has two parts. Arch model has two parts. One is mean equation, and the second one is variance equations. Okay, so now the question is that so here actually our model, this model actually, this model is actually arch model, right? There are 5 arch, and here is no GARCH. And here you can see what is the value of AIC and AIC. What is the value of AIC and SIC? You can see from here, Akaika information criteria and Schwartz criteria, right? There are two things. That we call it AIC and we call it SIC, suppose, right? We call it Schwartz information criteria. So Schwartz criteria, we can call it, okay. Okay, for this model, so what is the value of AIC? The value for this model is minus, you can see from here, minus 6.88. And what is the value of Schwarz criteria? Suppose I take it as a SIC. The value of SIC becomes minus 6.77, right? And what is the guideline? The guideline is lower the value, better the model, right? All the time. And here our target is to find out the best model having lowest AIC and SIC value. Okay, now now we should remember all the AIC and SIC value to compare. We should remember all the AIC and SIC value to compare. Okay. So here what is happening? The value of AIC and SIC is this one, right? 6.88 and 6.77. Okay. Okay. Now we shall develop another model, that is GARCH 1.1 model, right? GARCH 1.1 model. So I go to estimate. Then here is one arch and one GARCH. So I put here 1 and I put here 1. So arch 1 and GARCH 1, and I choose the normal distribution all the time to compare among all the models. So this model actually called GARCH 1.1 model. Okay, then I click OK. Okay, so that is the outcome. So this is my GARCH 1.1 model, and you can see this is arch 1, and this is GARCH 1, right? This is arch 1 and this is GARCH 1, and this one is the dependent variable, right? That is GARCH, meaning that the dependent variable is here, is called the variance of the residual. This is the dependent variable, and that is called variance of the residual, right? Variance of the residuals. And this residual actually we have derived from this mean model. So what is it? Variance of the residual. And this variance of the residual we have derived from the mean equation model, meaning that from here. Okay, then you can see our variance model, that is the variance model, and it is arch 1 and GARCH 1. Then what is the value of AIC? And so we have the two things, AIC and SIC. Okay, what is the value of AIC? The value of AIC is minus what? Minus 6.90, and SIC, suppose Schwarz criteria, I call it SIC. It is minus 6.84, right? You can see from here 6.84. So one is 6.9 minus 6.9 and 6.84. Okay. Okay, then our third model is called TARCH model. TARCH model. So meaning that our third model actually called TARCH model, or sometime it is called as GJR, GARCH, right? GARCH model, right? GJR, GARCH model. And here we can estimate it now. We can estimate it now. Okay, how to estimate? I go to estimate. Then here I put ARCH1, GARCH1. And here is one thing, threshold order. You can see threshold order. Here I put 1. Threshold order, I put here 1, right? I put here 1. And it is the Gaussian normal distribution. So other thing remain unchanged. Everything remain unchanged. Only here I put 1 to estimate TARCH model. So here I just put 1 to estimate TARCH model. So I press OK. So it is our TARCH model, right? It is our TARCH model, or sometime it is called GJR GARCH model. So it is our model, and here you can see. And here, what is the value of AIC and what is the value of SIC? So first I talk about AIC. Suppose Akaika minus 6.94. This one, right? Then what about Shoharj criteria? Suppose I write it SIC. Suppose the value is it is 6.86, right? This one 6.86. So one is 6.94 and one is 6.86. Okay. Okay. Then our fourth model is EGARCH model, right? EGARCH model. That is our last model. Okay, and how to estimate it? How to estimate it? Okay, how to estimate it? So I go to here, I click estimate. Then from here, I click here. Then I choose EGARCH. From here I choose EGARCH. So here there is a one arch and one GARCH, and the order should be 1. So that is our EGARCH model. So I click OK. I click OK. So this is the outcome of EGARCH model, right? And you can see from here EGARCH model. And here, what is the value of AIC and SIC? So AIC is about how much? Minus 6.92. And SIC is how much? It is minus 6.84. You can see. So one is 6.92 and 6.84. Okay. So we have estimated 4 models so far. We have estimated 4 models from ARCH family. Okay. And now question is that which model is the best out of all these 4? Now question is which model is the best fitted? Okay. And what is the guideline? The guideline is lower the value of AIC and SIC, better the model fitted. Okay, so that is the guideline. Okay, then the question is that out of 4 model, what is happening here out of 4 model? Okay, first I talk about first model was which one? The first model was ARCH 5 model, and their AIC is 6.88 and SIC was minus 6.77. Then second model GARCH 1.1, and here the value of AIC was 6.9 and SIC was 6.84. And the third model we developed was TARCH model, and their AIC was minus 6.9 and SIC 6.86, right? Okay, so that is called GARCH TARCH model. Then we have developed the last model, EGARCH model, where AIC is 6.92 and SIC is 6.84. Okay, out of these 4 models, I think the TARCH model is the best. TARCH model is the best because it has the lowest value of AIC and SIC. Yes, yes, should be. It has the lowest value of AIC and SIC. So the TARCH model is the best. So the TARCH is the best. So meaning that TARCH, or I can call it also GARCH model, is the best fitted model as it has the lowest value of AIC and SIC. Okay. So now the question is what about the diagnostic checking? What about the diagnostic checking of this model? What about the diagnostic checking of this ARCH model? Of this TARCH model. So meaning that whether this model has fulfilled all the condition or not, that we want to check now. Whether this model has fulfilled all the condition or not, that we shall be checking now. Okay, so far TARCH is the best model because she has the lowest value of AIC and the SIC. Okay, now the question is that whether this TARCH model has fulfilled all the condition or not, meaning that diagnostic checking that we shall do now. Diagnostic checking, right, of TARCH model. Okay. Okay. So the first one we check. Okay. First one we estimate this. TARCH model first, right? Okay. First one we estimate this TARCH model. I go to estimate. Then here I choose GARCH and TARCH. And here is ARCH1, GARCH1, and there should be 1. The order should be 1. So that is my TARCH model. Okay, then I press OK. So this is my TARCH model, right? This is my TARCH model. Okay. Okay. Now I first check whether this model has serial correlation or not. That I check first, right? Whether it has serial correlation or not. Okay, so I go to view. Then I go to residual diagnostic. Then I check correlogram squared residual, right? Correlogram squared residual. I do it first, right? Click on it. Okay, and suppose here I choose 36 lakhs. I choose 36 lakhs, then run it. Okay. And here is the Q statistics, right? And you can see the corresponding p-value. These are the p-values, right, of 36 lakhs. And here of this model, of this correlogram of standardized residual square, what is our null hypothesis? Null hypothesis is null is there is no serial correlation in the residual, right? So that is our null hypothesis. And you can see our p-value. So these are all p-value, right? All p-value. And you can see all the p-value are more than 5%. Suppose I talk about this one. This one, the value of p is 95.2%. Okay, what about this one? The value of p is 54.8%, meaning that more than 5%. So we cannot reject null hypothesis, meaning that we accept null hypothesis, meaning that there is no serial correlation in the model. So we are happy about it. We are happy about it. We are happy about it because there is no serial correlation in the model. Okay, then we check whether we have arch effect or not, right? Whether we have arch effect or not, that we check. How to check? I go to view, then residual diagnostic, then I check arch LM test, right? From here I click here, and here I choose arch, right? It is here arch, and click OK. Click OK. After clicking OK, the result of the arch test is here. You can see the arch test result is here, and it is observed R square, and it is the p-value. It is the p-value that is 82.64%. And what is our null hypothesis? That there is no arch effect, and that is desirable. Okay, and here what is the value of p? 82.64%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis. And that is and what is the null hypothesis? There is no arch effect. So in this model there is no arch effect. So we are also happy about the model, that there is no arch effect in the residual. Okay. Then finally, what about whether the residuals are normally distributed or not? Whether the residuals are normally distributed or not. Okay, so we can check it now. Okay, how? Okay, I go to view as before, then I go to residual diagnostic, then I choose histogram, the test of normality. I click here. So it is the outcome of the Jarka-Bera statistics and corresponding p-value, right? You can see Jarka-Bera statistics and corresponding p-value. And what is our null hypothesis? Null hypothesis is residuals are normally distributed. That is the null hypothesis. And alternative, residuals are not normally distributed. Okay, distributed. Okay. Okay, now here what is the probability value? It is 0%, right? Meaning that we can easily reject the null hypothesis and accept the alternative hypothesis, meaning that our residuals are not normally distributed and it is not desirable. And the question is that what is desirable? Residual should be normally distributed, but here residuals are not normally distributed. So we are not happy about this model, right? But this model has no serial correlation. This model has no arch effect, so we are happy about it. But only one problem is that residuals are not normally distributed. And many economists say that, many say that we can accept the model although the residuals are not normally distributed. Many economists say so, right? Many persons say so, right? Many persons say so, that although the residuals are not normally distributed, we can accept the model, right? And this model has two good things. has two good things, that there is no serial correlation and there is no arch effect. Okay, thank you very much for being with me for a while. Thank you very much for being with me for a while, Okay, so these are the terms of uses of this model.